I'm going to start the video here. Okay, so solutions. Before we start talking about how we calculate them and how, like, the math about it, let's do some not math. Okay, so there are two parts to every solution. There is the solute and the solvent. And when those two things are added together, they form a solution. Most solutions that we think of are liquid in nature. But anything that can get mixed together can be a solution. So we are breathing in a solution right now. The mixture of gases in the air is not 100% oxygen. In fact, it's not even mostly oxygen. And so that mixture, that combination is a solution. We just don't normally think of gases as a solution because we normally are thinking about liquids. Okay, have you seen these words before? Solute and solvent?
Yes.
Yeah.
Good. Solute is the thing being dissolved. And the solvent is the thing that does the dissolving. So I'm going to call it the dissolver. Normally we don't think of the word dissolve as having all of these different parts to it, or for it to be a noun, but it is. Okay, so the most common solvent is, yes. In fact, it has such a special name because it's so good at dissolving. It's called the universal solvent because mostly everything, and I use that term mostly, very loosely, but many things are dissolved in water, and therefore it's very good at dissolving. Some examples of solutions that we know from life. Anybody drink liquid IV?
Huh?
Okay, if you don't drink liquid IV, you should drink liquid. It's delicious. And it's it's a powder that you dissolve in water, and it's very high in electrolytes. It's like Gatorade, but like for on the go. So if you have your liquid IV, that would be an example. It has like 15 different flavors, and they are all delicious. My favorite is lemon lime. Golden cherry. Ooh, I've got sea berry today. I like golden cherry too.
I use them for football season.
Yeah, yep.
Swimming.
I just finally got Jake hooked on the liquid IV because he would never want to try it. He thought it was nasty. And then he was desperate. He didn't have any Gatorade left. And I was like, well, I've got liquid IV and like 6 bags of it. So pick a flavor. And so he tried the lemon lime. He's like, it's kind of like spicy because it's like a little more tart than it is sweet. The lemon lime, that's my favorite. He's like, it's really delicious. I want to drink it all the time. And I was like, all right. It is a little expensive, but it's not as expensive as buying like a pack. It's like about the same as like buying a pack of Gatorade. Plus, there's a lot less waste. You don't have as much plastic bottle waste if you're getting little packages. They're nice. So that's a good example. Another example of a solution that you probably are very familiar with, maybe in the morning. I think that Liz probably has some in her cup right now. Coffee is an example of a solution. What can you think of that might be an example of a solution?
Tea.
Yes.
I had some of that. My house was freezing.
I love me some tea.
I made tea with my.
I'm a wannabe British person.
I had peanut butter toast and tea for breakfast.
Okay, yeah, what kind of tea?
I don't know.
Black tea, green tea, fruity tea?
Whatever my mom has, I would just put in it.
Okay. He's not
Whatever my
fussy.
mom has, that kind of tea.
He's not fussy. All right, anybody else can think of a good example of a solution?
Like those flavored lemonade packets.
Yes. Yep. Any kind of packet, any kind of like drink mix, we'll call it. Do they still, Country Time lemonade? Do they still make those? Is that still a thing?
My brother makes it.
Okay, let's think about one more thing. So we're mostly thinking about liquids.
Jello.
What about cement?
So, that's a good example of what is not a solution. Thank you. So let's talk about that for a little bit. Something is not like our definition in chemistry of a solution if you don't have even composition throughout. So I'm going to say in English that means it's not perfectly mixed. Okay, so I'm just going to identify two potential problems in our list of examples here. Sometimes, if you don't use enough water for your liquid IV, like they tell you 16 ounces, I think that's too few. I put mine in my Yeti and I think that's like 26 ounces, and I think that's still very flavorful. Otherwise, it doesn't dissolve all the way, and if it doesn't dissolve all the way, if you have to shake it, it's not technically a solution. So anything that is not perfectly mixed or has to be shaken can't be this kind of solution. So orange juice has like, especially like the kind that has the pulp, Raise your hand if you like the pulpy orange juice.
I just like orange juice.
I hate orange juice.
I like that you can like chew it a little bit. I know it's so weird. I know it's so weird. It's not for everyone.
If there's two
Open
more.
their lemonade. I love Chick-fil-A's lemonade, but when I get home, I drain it of the pulp. Like I hate it so much.
Yeah, it's a real texture thing. If you have any medicine that you have to shake up before you use it, that's also an example of a not solution. Technically, soda also is not an example of a solution because soda is carbonated. And so what that means is that you're forcing carbon dioxide, that's the bubbles, into the liquid. And because you're forcing it in, like we know from experience that if we leave like a cup of soda out on the counter and we leave it out overnight, it doesn't have any fizz in the morning, right? That's because all of the carbon dioxide has evaporated out. It has to be forced into the liquid. It doesn't stay there naturally. So while you don't need to shake your soda, because that's probably not a good idea, it's not a solution because it's not evenly mixed. And it doesn't stay that way if you leave it at room temperature, like with the top off. I see that Logan, probably it looks like you have an example of a not solution on your desk. Because you're gonna probably, if you leave that there and you don't take any more sips, is that a protein?
Mm-hmm.
A protein shake or like a protein powder that you put in milk maybe? So he's probably not gonna take another sip. Like, let's say he doesn't take any more sips until 8:45. He probably is, Connor is helping him to not take any more sips. Would you take a sip without shaking it? After a half hour? Probably not, right? Because it'll be a little weird. That's an example of a not solution. It is way too early for this to be happening. It's got to be Spanish, right?
Yeah.
It's probably Gretchen and Jenna.
It's probably Porter. No, I don't think.
$10 says he didn't pull up to school this day.
Yeah,
He did not leave. Okay, we were already on the north side of Sheboygan, and he was just finally leaving the Fiserv. And then I said to Jake and Kate and Mills, he went with us. I was like, $10 says he doesn't come to school today. Him and Dawson Wheelers.
They were right on the floor.
They were on the floor. I saw Quirt for like the briefest of seconds, like on the monitor. And he was making a hilarious Quirt face. But it was just like the briefest of moments.
His story was pretty.
Okay, so what?
I was just a random monkey.
Well, because like the theme of the concert is like the title of it is Circus Maximus, and like the monkeys had like escaped from their like circus.
Okay, but he was just wandering around.
Yeah, that's yep. And only in one song there were the three monkeys, like three dudes dressed in monkey costumes, and they would just walk like this. And that was all they did, was just like walk around like the stage thing. It was, I didn't understand it, but I'm an old person, so.
This sounds so confusing.
It was like the show itself, like the spectacle of it was amazing. But like you're not there to see the spectacle. You're not there like the fireworks and like the fire and the everything. It's and like the loud booms and stuff. It's cool. It's like part of the experience. But like that's not why you're there, right? Like you're not there to be like visually entertained. You're watching a like internationally known music artist. Like you're there to hear. It's just like part of the whole sensory thing. So it wasn't weird.
What was your favorite song?
What was my favorite song? Goosebumps probably. That's probably my favorite. Jake was really bummed. He did not play Butterfly Effect, and that's his favorite. So he was bummed about that. But he did do Fiend like 8 times in a row at the end. So everybody was really looking forward to that. Okay, so how can we use solutions in the laboratory? Well, because we use solutions for so many different things, they have so many different applications. There's a way of doing the math for all of these applications. So let's talk about solution calculations. I'm going to hand out the purple sheet where you will find a whole bunch of different things. I don't know what I'm talking about individually. Oh, that's okay. If you can shake it, it's if you can drink it.
No.
I just was saying, like, if you didn't drink it for a half hour, would you drink it without shaking it? And, like, the thought of that just makes me. Okay, so let's take a look at this whole sheet really quickly. There are 7 formulas on the sheet, and one of them is one that you already know, number 7. So that's nice. That's nice that there's already there's something that's review. Yay. This isn't even all of the ways to calculate concentration. This is not even all of them. These are just the ones that are probably the most important. They all have a different application. The one I left off of here, do you see number 4 is called molarity?
Yeah.
There is also a concentration called molality, and it has only absolutely one application. We only use it in the lab for one thing. But, I mean, why not? Why not just have 80,000 ways of calculating a concentration of a solution? Because we can. All right, so let's talk about the first 3 of them together. So I'm going to start with numbers 1 through 3 on the purple sheet. I'm going to group those together because they are the same kind of math. Okay, so always you're going, in these first 3, you're just, everything is the same basically except what you have as your unit. So number 1 is called weight percent. Weight percent is also called mass percent. So in physics, weight and mass are not the same thing. In chemistry, they are. Because for us as chemists, we just need to be able to measure the mass, and the way that we do that on Earth is by finding its weight. So we call weight and mass the same thing. In real life, we do that as well. So if somebody were to say to you, how much do you weigh? And you said, I weigh 365 pounds. And you would give that, right? Okay, so we were at a basketball game, and Nick saw on the program that the opposing team, oh golly, who were we playing that week? I don't remember.
Probably Ballard, Billy.
No, it was maybe it was the Milwaukee Hamilton School. It said on their program that they had a kid who was 6'5" that weighed 365. And Nick's like, I'm staying for the varsity game because I need to see this specimen of humanity.
Was he that big?
There was nobody even close to this. And so he thinks that it was a typo. And then he was really kind of let down because he was hoping to see like absolutely an offensive lineman play basketball. Okay, so let's say that we've got this 365-pound basketball player. Pound is the unit for mass. It's not the unit for weight, but we call them the same thing. So don't need to worry about any of this. But if you do take physics next year, you'll learn that, or if, like Liz, you took it already, you'll learn that they're not the same thing but we don't really give a crap, so it's fine. Okay, so weight percent says that what we're going to do to calculate is find the weight of the solute. And now I am sorry, but there is no abbreviation for solute, solvent, or solution. I often will abbreviate the word solution as SOL''N or SOLN, but that's not even like a good abbreviation. And it's not standard, that's just something I do. Okay, so weight of solute divided by the weight of the solution. And because it's a percent, we have to multiply by 100. Okay, so this is nice if you're trying to solve for weight percent. If you're looking for anything else, algebra. And so for those of you who have a hard time with algebra, I don't want you to not be able to do chemistry because the math is getting in the way. This isn't a math class. So I'm going to give you the formulas now for how to solve for weight of solute and weight of solution. If you don't write this down on your purple sheet, this is going to be sad days. So this is pretty big writing and there's not a lot of space on here. So find a way that's convenient for you. Maybe using the back would be helpful. What I would do is I would try to write it really neatly, and I would maybe, there's like basically 6 formulas on here. I guess I would draw a line down the middle. Oh shoot. And then I would draw like I would make 8 boxes on the back. And I would number them 1 through 8. Well, 1 through 7. And that's what I would do. If I was you and I was having a hard time with my algebra, I'm great at algebra, so in real life I would never do this. But I don't expect you to be also great at algebra. I love algebra. It's a great day for me. I think I've told you guys this before. Like if I get to use the FOIL method, it's like everything is right with the world.
Couldn't disagree.
Connor couldn't disagree more.
Well, that's stupid.
Okay, so if you need to solve for the weight of the solution, this is what your formula will look like.
Yeah, that is really easy.
Also, be paying attention because I just did it. If you, like, the word solute is very similar to the word solution. So if you screw it up now, it'll always be screwed up. Okay, the weight of the solute is equal to, well, we would have to move 100 over to the other side, weight of solution to the other side. So this is what it'll look like. I'm going to abbreviate weight percent this way, and I'm going to multiply that times the weight of my solution, and I'm going to divide everything by 100. Good Lord. All right, so then we're going to need to solve for the weight of the solution. Now, my trick for algebra is, and this is not like cross multiply and divide, which doesn't actually always work. So your 4th grade math teacher, they lied to you. Yes, I know, stab right through the heart. Okay, so, but this is an algebraic trick that always works, and it's useful. Okay, so if you're solving for the denominator of a fraction, That's the bottom part of your fraction. All you need to do is switch this variable with whatever is on the other side of the equal sign. They just get switched. That's all there is to it. So what will that look like then? Well, weight of solution, everything is the same. Weight of solute is the same. Times 100 is the same. We just need to switch and get weight percent to go as the denominator now, and that's all there is to it. Do they teach you this? They should. It's very useful. And it never not works. Unlike cross multiply and divide. The reason that cross multiply and divide doesn't work is if you're solving for, like if you've got A divided by B equals C divided by D, if you're solving for either of these numerators in real life, your unit is upside down, and so you would have to take the reciprocal of it, and cross multiply and divide can't do that for you. Okay, so these are the three permutations, the three ways you would use equation number 1. Okay, let's do that same thing for equation number 2 now. So the reason that chemistry is so great and is the best of the sciences is because it's based completely on patterns. Better than physics. Yes, physics is like so case dependent.
I
And
really like biology. It was really easy.
Yeah, I was gonna
biology
say,
is easy, but there's no pattern. There's nothing like nothing is like constantly or always true. You can't like really you can make inferences from one thing to the next, but they're not like it's not always reliable. Chemistry is just reliable, it's logical, it's very linear. It's just better. So the next one is volume percent, right? This is exactly the same thing as the one we just did. The only thing that's different here is that before we were looking at weight of solute and weight of solution, now we have volume of solute and volume of solution. And in fact, my purple sheet is telling me, excuse me, it was really smoky. There was like a lot of, like, you know, they make like the stage smoke or whatever. But then the dudes that were sitting in front of us were using like the pot vapes. And so that it was just like, it was like a constant like,
How many people were stoned there?
like you're not allowed to. But like if you've got a vape, like, unless they catch you doing it, it's like odorless. So.
It's not really.
It's not.
Well, I mean, compared to actual
Oh.
Cigarette smoke.
cigarettes, yeah. Okay, so it does tell you that your unit here should be in milliliters. I'm just not going to write that here because I want to keep it a little cleaner. But just know that that should be your unit. Okay, so then let's say that we need to solve for volume of solute. If you look at what we just did, you should be able to apply the pattern from equation 1 to equation 2 as well.
What unit do we use for number 1?
I believe it says grams.
Okay. Oh yes, I see that now.
Let's see. We mostly don't ever use anything other than grams in the lab because our scales measure in grams.
Yeah, the metric system is better.
Let's see. Well, my brain turned off. What do we do? Oh, yes. Okay. Thank you. I apologize. Thank you, Connor. I have made it for a whole half an hour of teaching. I feel like this is some pretty excellent work right here. My husband, I was up when he got up at 6, and he's like, "What are you doing up?" Like, I would try to sleep as much as I possibly could. And I'm like, you know, I got 5 hours of like medium sleep. Like, I don't know how like different that is from like a normal night of sleep. I'm not good at sleeping, so I mean, I guess I have nothing really to bitch about. Okay, so then let me bring up this point here. Like, notice how I wrote V%? There's like a million ways of actually writing what volume percent is. So you can either have it as volume percent, like where the word is written out. You can write V %, or you can do this crazy V per V %. They all mean the same thing.
Alright.
So these are all aliases of the same criminal. So if you were gonna have, like, sometimes, like, you know how you like, oh, let's make up our criminal alias, so let's do it. We would all be like Lil, whatever. What was the last thing you ate? So my criminal name would be Lil Egg Waffle. Yeah, that strikes fear in the. Ooh, Lil Caramel. Ooh. Ooh, that's so cute. Anybody would be suspicious of Lil Muffin. Lil Egg. Oh, that's weird. Anybody eat anything weird?
Last thing I ate was a salad for dinner yesterday.
Lil salad. Little salad.
Okay, it was a sub and a salad.
Lil Muffin. I like Little Muffin. Little Muffin. Little Caramel. Lil Caramel.
Little bit.
Or like in Home Alone, you know, they're the wet bandits. Or then they become the sticky bandits in Home Alone 2. You could be the caramel bandits. You could be the muffin bandits. That sounds a lot like the Muffin Man, though. The Muffin Man. That, like, can you imagine, like, there would be like a serial killer who would like go by the name of the Muffin Man.
That would be so creepy.
There's your next like Halloween movie.
And when he kills them, he puts a muffin in their mouth. Did I say what the prank you wanted to do? That's a good idea.
That is. That's how leave your calling card. Or you could kill them using, like, making them choke on a muffin.
Like, how do you keep that in there?
You have razor blades hidden in the
What if you
muffin.
just eat it?
Oh yeah, what if you just were a hungry person? I can't kill you today. I need to eat the muffin. Oh, this muffin smells too good.
Eats the wrong
Like
muffin.
one of those
I can't kill people with a Raisin Bran muffin.
It's a grenade.
What if it's a biological weapon and it's a grenade that doesn't go off till it's like in your stomach?
This sounds like something Dylan would come up with.
Okay, so maybe I am more tired than I thought. Yes, this is like Snowmageddon.
Just me.
The muffin could be laced with something.
Yeah, true.
Yeah, because you're going to use this one today.
This Bishop just sounds like a story of making shirts out of birds. But illegal birds. And shipping them to Remington without a package job.
Oh my gosh. Yes, the birds. The birds, the illegal birds, the protected birds.
And he'd be so skilled at doing it that it would be all over the news and no one could find him until they get denied anonymous calls.
Oh, Dylan.
Yeah, you would take
So Dylan scored a 5 on the autism test, and
I did too.
and we were all like, no. So then me and Lindsay took it like as we like pretending we were Dylan, and we only got a 10.
Like you tremble.
Oops, what did I do? Okay, so I wrote down the last combination. Lennon also got a 7, but we don't think he knew how to answer the questions.
Oh, Miss Bishop, I didn't.
Oh, sorry, thank you.
I was too busy laughing.
See, I just get stressed around other people. I literally don't really like understand the appeal of having friends that much because it makes me stressed.
I got really stressed out last night because Caden had the parking ticket on his phone, and so he put the address for the parking garage in my phone, and I was like, I don't know which like parking garage like in Milwaukee. There's like 35,000, and I was like getting like so anxious because you know how I am with spaces. And I was like, I don't know, like where this thing is or like what it is, and like my palms are getting sweaty just thinking about it. Like that made me so anxious.
Like we were just saying how like
You're gonna recognize it.
sometimes like I feel like it was easier though because like he performed in the Pfizer, so like
With a shot.
sometimes when like these bigger like not bigger artists but like well known but like not as big as like
Obviously, you gotta
Swift
agree.
or something.
Right.
But, like when they
Yeah.
come like they don't perform at like bigger
Just gonna be
bigger
close to
venues, so it's like
And
it is kind of sketchy like finding them because they're just in like an awkward like
Yeah.
area or like something like
Yeah, it's
really
not
kind
like
of-
it's not like an arena.
yeah,
It's like
yeah.
or like even like the Pabst Theater, like the Riverside
Yeah,
Theater, like
yeah.
those are like established, like they could be like in like a dive bar or
Yeah,
like or like I
exactly.
think about something like Sabbatical Brewing. Do you know where that is? It's over by like Hobby Lobby area, like a place like that, but like in a mega big city.
Mhm. Yeah.
Or like I think about all like the things that we saw when we were in college that were like in like random ass buildings.
Mhm.
And you don't know where anything is or like where the door to anything is because they're all like attached to each other. It's
Kelsey's girlfriend's kind of big.
Well, that's how
Yeah.
it's, like,
okay, so now solution number 3. Let's do solution number 3 and get the and like learn about this, and then I'll give us a nice little brain break. Solution number 3 is like a combination of 1 and 2. So it's called weight per volume percent. And it's truly what this says here describes what it is. So it's the weight of the solute divided in grams divided by the volume of the solution. So truly this is a combination of 1. This is equation number 1. This is equation number 2. With those powers combined, we have equation number 3.
Some Power Rangers type stuff like
Indeed.
that. I can watch that for years.
My brother loved Power Rangers. Like the OG Power
Yeah,
Rangers.
there's so many. The new ones are so bad.
Like the acting.
Carter
Whew.
was watching one the other day. He just had it on TV. And I was, this is horrible. Put on
Yeah,
something
it's hard to
standard.
watch. Okay, so then let's do the 2 permutations after this. So let's solve for weight of solute. So follow the pattern that we did on number 1 and number 2. To solve for the weight of the solute, we will have weight per volume percent times the volume of the solution divided by 100. And then for volume of solution, we would have just, that's where we're going to like flip our things again. Weight percent becomes on the bottom, or weight per volume percent comes on the bottom, times 100. Okay, so now we know what the first 3 solution calculation formulas are. Let's take a little brain break and then I will give you your homework and we'll learn how to use them. So I'm gonna press pause on here.